everyone. In this video, we're going to be taking a look at how to take the derivative of a logarithmic function. So the first thing I want to do is develop our theorem, develop our rule, and then I want to use that in a couple examples. So to begin, let's say we have a logarithmic function. So let's say we have the equation y is equal to the log base a of x. And we want to be able to take the derivative of this. The first step in being able to do that is we actually need to remember the property of logarithms, where we can rearrange this. So this equation is equivalent to x is equal to a to the y power. Now the reason we want to switch it is because we do already know how to take the derivative of an exponential. So from here, we're going to find the derivative of this using implicit differentiation. So let's take the derivative with respect to x of both sides. On the left-hand side, we're just taking the derivative of x, which is just equal to 1. And on the right-hand side, we're going to be taking the derivative of this exponential, which, if you remember, is equal to the exponential itself times the natural log of whatever the base is. And since this is with the variable y, we are going to include dy over dx. The next step, we need to solve for dy over dx. So let's divide by our exponential and the natural log. So we get dy over dx is equal to 1 over a to the y times the natural log of a. Now we're actually going to do one more step. I end up with the derivative here that has a y in the denominator. I want this to be in terms of x. But in the very beginning, we said x is equal to that exponential. So let's substitute that out. So we end up with our derivative, dy over dx, is equal to 1 over x times the natural log of a. And this is how we find the derivative of a logarithmic function. Any base will work here, which means that we can also simplify this a little bit more if we're dealing with a base e. So let's say we have y is equal to the natural log of x. In natural log, the base here is e. So if I use my theorem, my formula we just found, dy over dx is going to be equal to 1 over x times the natural log of e, because the base was e. However, we know that the natural log of e just simplifies to 1, so the derivative of the natural logarithmic function just ends up being 1 over x, which is nice and clean and simple. Okay, so now that we've established these two rules, let's use them in a couple examples. Okay, so my examples, the first one, I have y is equal to the natural log of x, and that is squared. So we can use our new rule for natural log to find the derivative, but I am also going to need to use the chain rule here because this is expressed as a composite function. So y prime, following our chain rule, the 2 is going to come down out front, and then we're going to multiply this by the natural log of x. We're going to subtract 1 from the exponent, but I'm not going to write the exponent of 1 here, we don't need to. And then we need to multiply this by the derivative of the inside. So the derivative of natural log of x, as we just saw, that's equal to 1 over x. And just to rewrite this, we have 2 natural log of x all over x. And there's our derivative. Okay, the second example, I have y is equal to 1/2 times the log of x. So the first thing, and really the main thing that we need to note here, is that this is written as common log. So when the base isn't indicated, that means we're looking at common log, which means that this is base 10. This is what the button on your calculator does. So as long as I know that the base here is 10, I can use my rule to find the derivative. So y prime, we still have our 1/2 out front, and then multiplying by the derivative of the log of x, we get 1 over x times the natural log of 10. And I'm going to combine those two fractions together. So we get y prime, we get 1 over 2x times the natural log of 10. So there we go. So that's how we use the new rules to find the derivative of logarithmic functions. And as you can see here, we can combine that together with some of our previous rules as well.